Hello, everybody. How are you doing? It's week 6. It's the second assignment, so it is 6.2. We're going to do a little bit different stuff today. I was really looking forward to a day at the end of the semester, a fun day where we could just have some fun with math and explore some things that you may not know about the subject. Some things that I am really passionate about math, maybe some tricks, maybe some cool math history, some fun challenging problems. So that's what I'm going to start doing is I'm going to start slipping in some fun lessons, all right? Some really, not that they're not all fun, but I've got some really cool stuff for you coming up, all right? Today's going to be kind of like a little history lesson and a little, you're going to put a little trick up your sleeve, a cool, fun party trick to show your friends, all right? So this is going to start with me asking, here's my challenge. Add up the first 3 natural numbers. First, we're going to define what a natural number is. So the natural numbers, we usually write the set with this nice kind of script N. The natural numbers, all right, this is identifying natural numbers. It's really all of our counting numbers. So it's the set of numbers 1, 2, 3, 4, 5, 6, 7, 1,000,002, 1,000,003. It keeps going on until infinity, basically. It's this huge set of just all of our positive integers, 1 to infinity, all right? And my first challenge is add up the 3 natural numbers. That's not too bad. I can add that up real quick and say, cool, it's 6, rock on. And then I say, add up the first 5 natural numbers. All right, I can do that. You add them up and you get a 15, not too bad. What if I say add up the first 8 natural numbers? Okay, I can do that. Maybe you want to make it a little quicker, plug it all into your calculator. That's still a lot of buttons to type. You sit there with some mental math. Maybe you carry a 1 or you don't carry a 1 and it gets a little messed up. But, you add them up and you get 36. Maybe it took a minute there. And then I say, I don't know if you know where I'm going with this. Add up the first 100 natural numbers. And yeah. I don't want to do that. I don't want to write out 1 to 100 with a whole bunch of plus signs and have to add them up. I don't even want to have to touch that in my calculator, right? I don't want to type that. That's way too much. That's what this guy, Carl Friedrich Gauss, said, all right? So in the late 1700s, when this guy, Gauss, was going to elementary school, his teacher said, you know what, guys? You're driving me crazy, and he gave some busy work, and the teacher said, I want you to add up all of the numbers from 1 to 100. Go. And Carl Friedrich Gauss said, no way, Jose. Forget that. I'm not adding up all of the 100 numbers. I'm not doing that. That's going to take way too much time. So he found an easier way to do it, and I'm going to share that with you here, all right? And just so you know, Carl Friedrich Gauss, if you've ever heard of Gaussian elimination, when you solve systems of linear equations using elimination, it's technically called Gaussian elimination, but we just kind of drop it and say elimination. Anyway, this guy Gauss, he's a cool dude. I'm trying to convince you of that. He's a cool dude. Anyway, let's go. All of the examples start with 100 natural numbers, and that's what he did as an elementary school. He looked at that and he basically came up with a formula to find that sum. I'm just going to jump down to the easier problems, and we will work our way up to the harder ones real quick, okay? So, here's my challenge. The first 3 natural numbers. It's not too bad, but, this Gauss guy is like, is there an easier way we could do this? He starts playing around with some numbers, and he's like, let's just try and write them backwards, okay? So he's got 1 plus 2 plus 3, and then underneath he wrote 3 plus 2 plus 1. And he said, okay, if I add up all of these numbers together, so let's just say I add all of that, right? Since I'm double counting my numbers, my sum, the sum of the first 3 natural numbers, should be twice of what I'm counting, right? So basically this is what he did. He did 1 plus 3. He saw that was 4. He saw that 2 plus 2 is also 4. And he saw that 3 plus 1 is also 4, right? So then he just had to do 4 plus 4 plus 4, and you could see that is 3 groups of 4. It's 3 times 4, right? which gets you 12. But again, since you double counted all of these numbers, right, you have to account for that, and you have to divide by 2. You have to half that sum, right? So 12 divided by 2 would give you 6. And that's what we got in the beginning, right? It's kind of cool, right? Let's keep going. So again, with this kind of trick of recognizing that you could add these numbers up together, right? And they would give you like the same sum every time. We're just going to, again, rewrite this, but now backwards underneath our original numbers. So 5 plus 4 plus 3 plus 2 plus 1. I'm going to erase this 15 real quick. If you add up all of those again, well, 1 plus 5 is 6. Oh my gosh, 2 plus 4 is 6. 3 plus 3 is, not 3, it is 6. 4 plus 2 is another 6. And that 5 plus 1 at the end is another 6. How many groups of 6 do you have? I have 1, 2, 3, 4, 5. So I really have 5 times 6. And since that's 30. Whoops. That's 30. And since I double counted this sum. I've added these numbers twice in here. Since I did that, I have to divide by 2 to account for double adding it, right? And that will get me 15. And that's what we came up with at the beginning, right? This 15 and 15. So this is looking like it's a pretty cool trick. Let's do the same thing one more time. So 8 plus 7. I'm just going to rewrite all of this backwards and then add them up vertically. 8 plus 7 plus 6 plus 5 plus 4 plus 3, 2 plus 1. If I add up all of these vertically, you're going to get 9 plus 9. You're going to get a whole bunch of 9s added together. And since we had 8 numbers that we're originally adding, we had 8 9s. 1, 2, 3, 4, 5, 6, 7, 8. Oops, there's 8 9s there, so there's 8 groups of 9. 8 groups of 9 is 72, but since I double counted that sum, again, I have to divide by 2. 72 divided by 2 gets you 36, all right? And that's what we came up with at the beginning. So this is checking out, all right? So this is what Carl did. Gauss, he said 1 plus 2 plus 3 plus 4 plus a whole bunch of numbers in the beginning or in the middle, right? Plus 96 plus 97 plus 98 plus 100. And he said, okay, let me write them backwards. So 100 plus 99 plus 98 plus 90. Oh my gosh, can I count? 97 plus a whole bunch of numbers in the beginning, right? Plus 5 plus 4 plus 3 plus 2 plus 1. Okay, and you recognize that all of these pairs, if you wrote them like this, all of these pairs add up to the same number. Same thing like what we did before. So 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101 plus 101. You're adding up a whole bunch of 101s, right? Dot, 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 plus another 101 at the end, a whole bunch of 101. Essentially what you got here is you have 100 groups of 101. So 100 times 101. Again, since we double counted these numbers when we added them together, we have to divide by 2. So 100 times 101 divided by 2 is going to get you this special number of 50. So if we want to generalize this formula, for any number, so if I said, I want you to find all of the sum of all the numbers from 1 to 57, or from 1 to 203, right? I want to find it for any value n, for the first n numbers, for the first n natural numbers, right? If we want to generalize this formula, we could say, well, here it was the first 100 natural numbers, and we took 100 times 100 plus 1, the number that was greater than it, and then divided it by 2. So let's just write it like this. So we're going to say that this, oops, not in highlighter. We're going to say that the sum of the sum of first n natural numbers can be written using this formula. If you take that number n, if you multiply n times n plus 1, the number right after n, like what we did here. We had 100 and we multiplied it by 101. We just added 1 onto this n value. And then since we've been double counting these numbers, we have to divide by 2. Then that would be our formula here. So if I want, so this formula, n times n plus 1 divided by 2. If I use that on any of these here, let's check and make sure. If I want the first 3 natural numbers, again, I'm going to have this formula of n times n plus 1 divided by 2. Let's plug in 3 in for n here in these two places. So that gives me 3 times 3 plus 1 divided by 2. Well, that's 3 times 4 divided by 2. That's 12 divided by 2. Yeah, that's 6. That checks out. Let's see. Let's use now n equals 5, because we want the first 5 natural numbers. So I'm going to say 5 times 5 plus 1 divided by 2. Well, that's going to get you 5 times 6 divided by 2, which is 30 divided by 2, which is indeed 15. That checks out again as well. All right, so down here with the first 8 natural numbers, now we have n equals 8. 8 times 8 plus 1 divided by 2. Well, that's 8 times 9 divided by 2, which is 72 divided by 2, which is, oh my gosh, it's that 36 that we came up with. So this formula of n times n plus 1 over 2 works. All right? Wonderful, wonderful. I'm going to attach a little clip. It's really funny. It's pretty cute. It's the same thing. I suggest you watch it. And yeah, I'm going to ask you a couple questions. Can you add up the sum of the first 250 natural numbers? So basically you would use this formula and you would plug in 250 in for n. All right, and that would get you the sum of the first 250 natural numbers. All right, I'll give a little extra as well. This here, if we wanted to write this as like a proper sum, which you may encounter in later math, you would say the sum from the number, this is like, if you're looking for proper notation, this is what we call summation notation. So this is summation notation. This thing here is basically just says sum, right? Sum up all of these numbers, all right? So if we wanted the sum from all of the numbers 1 to n, where we're adding just a whole bunch of n's, it would be the same thing as using this formula, n times n plus 1 over 2, okay? So this is just a little bit extra. This thing means sum, but really I would like you to know how to use this cool formula. So, hey, maybe when we're all allowed to go back to, regular distancing, you go have a birthday party with your friends and say, hey guys, I got a trick for you. Why don't you sit there? Let's see who can add up all of the numbers from 1 to 300 the fastest. But guess what? You've got a little trick up your sleeve. Meanwhile, your friends are going, oh, why do we have to do this? Anyway, it's fun. Have fun. Carl Friedrich Gauss. Where is he? There he is. He's a cool dude. Anyway, have a great day, guys. Go watch that video. The extra video is really funny. It's really cute. And then there's a couple questions as an assignment. Have a great day. Adios.